So x squared over x plus 5 minus 25. Okay, two fractions, they have the exact same denominator, so that means you can rewrite it as one fraction with that denominator, and then you do the tops, x squared minus 25, and you can't combine anything because they're different terms, right? But what does x squared minus 25 look like to you? Difference of squares. So then you rewrite that as x minus 5, x plus 5. Bless you. What looks like a sad face?
Bless you.
Equals x minus 5. Okay? What? Where do you see a sad face? Oh, I do see the sad face. Okay, yes, I see. I do now. So, okay, this warm-up was the last material that we went over. Okay, adding fractions with the same denominator. Today we're going to be adding fractions that start out with different denominators. Yes, we have to find common denominators. So to begin, we are adding fractions that have variables in them with different denominators, okay? I want to just real quickly review how we add fractions that are just regular numbers. So that's why I have that 1/4 plus 2/3. Do you remember offhand how to handle 1/4 plus 2/3? Like, what would you do? Yeah, because you're trying to get what for a common denominator? 12, okay? So one thing we have to do here is we're switching our minds away from greatest common factor. Greatest common factor is, so when we're doing this with regular fractions, I would probably ask you something like this. I would say, we need a common denominator. What number do both 4 and 3 go into? And you would say 12, right? Now, that's how we would work that problem. So we would say the LCD is 12. And then what we would do is rewrite each one to have that denominator. So I would take the original fractions, and then I would ask you, okay, what do I have to multiply this denominator of 4 by to get 12? And you would say 3. And then I would say, you have to do that to the bottom and the top, right? Because we're just rewriting it with the common denominator. We're not changing value or anything. And then we go to the other fraction, right? And I would say 3 times what would give me 12? And you would say 4. And I would say, you have to do it to the bottom and the top. Right, and so then we do that actual math. And so the next step says add or subtract across the top. So I would write one new fraction with my common denominator. That would give me 3 in the first fraction and 8 in the second. 11 over 12. And I would try to simplify if I could, but I can't. So I would just be done. For fractions, okay? For with regular numbers. But then when I get to problems with variables in them, it gets a little bit trickier. Like if I were to say, what denominator can x squared minus 4 and x minus 2 go into? It's x squared minus 4. The problem is, with all these different, like if you're looking at these examples down here, they have all different kinds of forms on their denominators, and your brain has to be able to work with all the different ways. And so what I'm going to do this time, what I'm going to do here in this case, when I'm trying to figure out the LCD is, I'm first going to start by factoring the denominators. So we can see all the factors that build up each denominator. So in this first example, how do I factor this denominator, x squared minus 4? Okay, that's difference of squares, right? And for the second denominator, it doesn't factor at all. Please remember, when there's a minus here, that's just 2 terms being subtracted. So we just have to group those together. So this is just x minus 2, all right, in the second one. It's not an x times a negative 2. It's x minus 2. We have to group them together. So then when we go figure out what their LCD is, we have to build one denominator that has every factor in it. So for both of these pieces in the first denominator, I need an x plus 2 and an x minus 2. And then that's it, because in the second denominator, I need an x minus 2, but guess what? I already have it. So then this is my least common denominator. So then to go do this Third step with the black and the blue ink, I do, in black ink, again, I'm going to do the original problem, but this time in the factored form. So 3x over x plus 2 times x minus 2 plus 4 over x minus 2. And then I multiply the top and bottom by whatever I need to get the common denominator. So in this first fraction, what do I need to multiply the bottom by to get this? Nothing, right? It's already there. So I don't have to change it at all. But what about the second one? X plus 2. Okay, I need an x plus 2 to look like that. So it's gonna, and I have to multiply that to the bottom and the top. So then I rewrite it with one big fraction. The denominator is x plus 2, x minus 2. In my numerators, I have 3x plus, well, I have 4 times that x plus 2. So I'm going to distribute. Distribute, distribute. So that's 4x plus 8. And then what can combine in that numerator? The 3x and the 4x. So that gives me 7x plus 8. And you can either leave the denominator as x plus 2, x minus 2, or rewrite it as x squared minus 4, whichever you like. They're both fine for me. And what we're going to do for the rest of class, our goal is to get through just these first 4 problems. All right? We'll talk about the rest tomorrow. The thing is that if you look at each of the denominators, they all begin differently. Like in this example problem, we had x squared minus 4, x minus 2. But we need to be able to handle these different kinds. Like there's no plus or minus in these denominators. There's no plus or minus here. But the basic idea is still the same. So let's talk about how it looks for even other kinds of problems. So in this example, we still need to figure out the least common denominator. And I recommend you do that like this. Think about it, the numbers first and then the variables, for example. If it was just 3 and 4, it'd be 12. Okay, so the number part of the denominator is 12. But I also need, so let's look at the a's. How many a's do they have in common? None, but to make it a common denominator, I need at least this one a. And then I need at least that b. So then we go to the original ones and we multiply the top and bottom by whatever we need. So what do I have to multiply this denominator by to get 12ab? 4b to the top and the bottom. Yeah, and then the other one is 3a. So I rewrite it as one big fraction with a denominator of 12ab. I multiply these numerators, that gives me 4b plus 1 times 3a. And I can't simplify anything else there. I'm done. Yeah, so that's it on that one. For number 2, though, to build my least common denominator, I look at the numbers first. What's the smallest number that 4 and 6 go into? 12 again, okay? Then I look at x squared and x. What's the smallest amount of x's I need to represent both of those pieces? X squared. Because if I just put 1x, that's good for this denominator, but not this one, right? I need the most number of x's that occurs in either one. And then how many y's do I need to represent? Right, 2, y squared. Okay. That way, every piece of each denominator is represented in this common one. It's what they, and it's not what they have in common right now. It's what do they need to cover up everything they have. It's kind of like this is the denominator party, and all these things are invited. We have to have everything showing up at that one party. Okay. So then to rewrite the original equation, or expression rather, what do I need to multiply 4x squared by to get the common denominator? 3, right? 4 times 3 is 12. Already has the x squared, and then y squared. And I have to do it to the top and the bottom. And then for the second fraction, 6 times what gives me 12? X times what gives me x squared? And y squared's already all represented. So I have to do 2x to both of those. So then rewriting it as one big fraction, the common denominator goes on the bottom, 12x squared y squared, 3y squared times 1 plus 5 times 2x is 10x. And I can't combine anything there. There's nothing else that I can factor or simplify. So it's just done. What is the main difference for number 3 in these denominators and the two problems we just did? This minus 5, right? So this one works a little bit differently. This is not a times a negative 5, right? It's a minus 5. That minus means this is a group of things that we can't break apart. We can only break apart stuff that's being multiplied. This is not. So when we go to build the LCD, don't holler anything out. The common denominator has to represent this piece, and it needs to represent this piece. What do you think that would look like then? A times a minus 5. Okay, a times a minus 5. So I take my original fractions. What do I need to multiply the first one by? Good. A minus 5 on the top and bottom. What about the second one? Just a, top and bottom. So then I rewrite everything with the same denominator, which was a times a minus 5. I distribute this 2, so that gives me 2a minus 10. And for the second fraction, I get minus 3a. What combines in the numerator? 2a and the minus 3a. So that's minus a minus 10 all over a times a minus 5. And there's nothing left to factor there, so I can't really cancel anything out. And I want you to take a minute and try number 4. Okay. One thing about finding the LCD here. Remember that the denominators have the grouping, right? So it's this and this. So to build the LCD, C plus 2 as a group has to be in there, and C minus 3 as a group has to be in there. But we're not actually going to FOIL those or anything. We're just going to use them for the rest of the problem. So when I go to my two fractions, my original ones. What do I need to multiply c plus 2 to get the LCD? C minus 3 on top and bottom. And over here, c minus 3 needs to be times c plus 2. So then rewriting everything as one big fraction, the common denominator is c plus 2 times c minus 3. And then here in the numerator, I distribute that 5. 5c minus 15. And Maggie, I think you were doing that step 1. I think you did that one step early, right? Did you have 5 times 5c minus 15? I think you were doing it in your head, but did it, and then you wrote that through. And then here, multiplying that through, it's plus 6c plus 12. And then combining like terms gives me 5c plus 6c is 11c minus 3 all over c plus 2 times c minus 3. Okay. We are going to work more on these problems tomorrow. I was just going to do this one lesson today. We have a whole other lesson we need to do before Friday's test. One more section of new material, but we're going to push that back one day. One thing I want to tell you about this skill, the least common denominator, we will be using this again even after this unit because we have to solve equations that have these fractions in them, and we'll be using the LCD then as well. So it's not going away. Factoring's not going away.